Hello everyone, my name is Hayfa and I'm very excited to be sharing with you this video that discusses the research project I worked on during my Concordia undergrad summer research award in 2021. The project was part of the ongoing research conducted by Dr. Karen Lee and her team in the Laboratory for Adult Development and Cognitive Aging at Concordia University in Montreal. The name of the project is Dual Mechanisms of Control and Postural Recovery in Older Adults. To start off, I will present some background information that highlights the importance and relevancy of this topic. Then, I will tell you a little bit about the project itself, including the study design and the methods. Additionally, I will share some results, and finally, I will tell you about the amazing team that made this project a success. To begin with, I want to highlight some important findings in previous studies. There is evidence that older adults exhibit an enhanced fall risk when compared to younger adults. Reasons that might explain this are increase in age, medication use, cognitive impairment, and sensory deficits. However, the age-related deterioration of executive function hugely contributes to this increased fall risk. So, what is executive function? It's a set of higher order cognitive processes and mental skills that help us plan, monitor, and successfully execute our goals. They involve processes that help us self-monitor, control our emotions, organize, plan, update information within our working memory, task inhibition, and so on. These functions decline naturally with age. Previous research that involved the use of neuropsychological tests have revealed that there are age differences in deficits related to attention, inhibition, and working memory. A good model that describes these deficits is the dual mechanism cognitive control model by Braver, in which he stipulated that context processing mediates these components of executive function. Context processing enables our goal representations to direct our attention towards cues that are relevant to our goals and maintain these cues within working memory, and to also direct our attention away from cues that are irrelevant to our goals. For our study, we sought to apply the DMC model to gross motor control. This simply means that we examined the context processing and postural control across older adults versus younger adults. The study was composed of two cohorts. Cohort 1 was older adults aged between 60 and 80 years old. The second one was younger adults aged between 18 and 35 years old. Now let's discuss the project. We first conducted telephone screening to determine the admissibility of participants, and we invited admissible participants to do a session 1 in the psychology department of Concordia University. During this session, we conducted some neuropsychological tests that I will discuss with you in a moment. Then, upon inspecting the results of these tests, we invited those who qualified to do a session 2 in which we did a postural recovery task at the Postural and Movement Lab in the Perform Center. During a typical visit to our lab, we performed the following list of neuropsychological tests. We did the MOCA, the Stroop, the letter number sequencing, digital symbol coding, trial making, and fine motor AX-CPT task. Now, let's discuss each of these tests in more details. First, the Montreal Cognitive Assessment, or MOCA. We used it our global cognitive screener. Participants answered questions that assessed visual executive function, naming things, memory and attention, language fluency, delayed recall, and orientation. The second task was the Stroop. We administered to evaluate response inhibition. This task requires inhibiting preponderant responses to incongruent information such as the word of the color mismatching with that of the ink. The next task was letter number sequences, and we used it to assess working memory. In this task, we read a sequence of numbers and letters to the participants, and then we asked them to recall those numbers and letters in alphanumeric order. Next, we administered the digital symbol coding to measure processing speed. The goal of this task is for participants to correctly assign as many symbols as they can to a list of corresponding digits within 2 minutes. Next, we use the trail-making task to assess attention and cognitive flexibility. This task had two conditions. Part A is the attention condition, and part B is the switching condition. In part A, we ask the participants to connect the numbers in ascending numerical order as fast as they can without making mistakes. In part B, which is the switching condition, we ask participants to connect the circles in ascendant alphanumeric order while alternating between a number and a letter. So for this part, the participant is to connect from 1 to A, then to 2 to B, to 3 to C, and so on. Finally, we used the fine motor AXCPT to assess context processing. The participants were presented with a letter cue that only appeared briefly, and after a short delay during which the cue information must be actively maintained within working memory, the letter probe is presented. Upon presentation of the letter probe, participants were instructed to make a response as quickly as possible. Specifically, participants are instructed to make a target response to the trial type AX, which was correct, and to make a non-target response to all other combinations such as B followed by X, which was incorrect. This task marked the end of session 1, and only qualified participants were invited to do a session 2 at the Postural and Movement Lab at the Perform Center. During this session 2, we conducted a posture recovery task. On the screen is a picture of a participant who agreed to take her picture and allow us to use it. As you can see from the picture, there are a few things hooked up to the participant while she performed the task. First, we prepared her and placed reflective markers on her body to capture her 3D body motion. We also placed electromyography sensors on specific muscles to measure their activity. After the preparation stage is complete, the participant was told to stand on the moving platform while she performed a modified version of the AX-CPT task. More precisely, the participant was told that if she saw the AX combination, the platform was more likely to move. And if she saw any other combination, the platform was not likely to move. We took precautions to ensure the safety of each participant, such as attaching them to a harness to prevent them from falling. We are still at the data collection stage, but from our preliminary results, we have evidence that the DMC framework is involved in the context of gross motor control, which is balancing. Also, we found age differences in how younger adults and older adults use the cues to help balance themselves, in the sense where younger adults use cues more efficiently. Moreover, cognitive measures of DMC framework also predicted performance in the motor AX-CPT task. As I said earlier, we are still collecting our data. As our sample size is increasing, our confidence in the results is growing. This leads me to the end of my presentation. I would like to thank Dr. Karen Lee for accepting to supervise my KUSRA project and giving me the chance to be part of her lab and for teaching me many valuable research skills. I would like to thank Laurence for mentoring me and teaching me the experimental protocol. I would like to thank everyone from the Lee Lab for their contribution to this project, notably Elnaz, Emma, and Nathan. Thank you so much. I hope this information was informative.